fire always comes up as something that human beings could be affecting. Are we increasing the number of fires? Are we somehow making fires worse, and so on? And then, of course, there is the concern about the emissions from fires in the Earth system. As we saw before, the management of fires by human beings is a bigger concern in terms of whether that's a beneficial thing or not for the overall health of the forests and its interaction with the warming. So we'll touch on those issues a little bit here. This is a schematic from the book showing fire functioning and feedbacks in the Earth system. It illustrates three requisites for fire to occur. When you have a trigger or what do you call a way to set off fires, a sufficient amount of fuel has to be available. It has to be sufficiently dry, and the ignition source. That's what I meant, ignition source, right? So lightning lightning typically serves as the ignition source over history for natural wildfires, and the question is, how has human encroachment on vegetated sites, forests, and management of fires, management of forests, perturbation of forests, etc., have affected fire and its interaction with climate. So look at this rather complicated looking thing. You have atmospheric chemistry on one side and soils, because they supply the vegetation and the fuel, on the other side, with fire sitting here, which obviously affects nutrient supply in terms of the conversion of the organic carbon back into preformed nutrients. So that's soil properties are going to affect the fuel quantity. So land cover and vegetation composition are going to be affected by that. Fire also affects deforestation, plant mortality and reproduction, and so on. So fires have been part of the natural cycle for a long time. Question again is whether their intensity, duration, and frequency are changing, which relates to land use change, like logging and agriculture, which affects land cover and vegetation composition, which affects the fuel amounts and fuel availability and dryness, etc. So there is less confidence in the impact of land cover and vegetation onto rainfall, radiation, temperature, and CO2. Whereas the climate impacts on land cover and vegetation composition is somewhat better known. So atmospheric chemistry and climate, we already saw the interactions between nitrous oxide, methane, carbon dioxide, and so on. And climate impacts overall in terms of rainfall and temperature are going to affect fuel moisture and fire itself. You can also have direct wind effects. Actually, it turns out that when the fire gets large enough, like it did in California or Australia, California in 2020 and Australia in 2011, 2019, if I'm not mistaken, the heat source becomes so large that they begin to generate their own weather. So that can be an issue as well. And of course, you have lightning as ignition source and human land use as well. Okay, so there are trace gases and aerosol emissions. There are impacts on albedo, water, and energy fluxes that complete kind of the feedback loops. So in the model, you want to be able to put in these pieces, and of course there is lots of uncertainty in putting ignition sources via lightning into the model, but lots of lightning data now exists from satellites like the Tropical Rainfall Measuring Mission and the follow-on mission like the Global Precipitation Measurement, or GPM. Colin Prentice, one of the editors of this book and authors of some chapters, has had a vegetation interaction model. So it has vegetation dynamics, soil moisture, tracks various essential climate variables like maximum minimum temperatures, precipitation, wet days. There are various indices. Litter moisture includes crop area, so there are prognostic variables like fire spread, intensity, burned area, combustion, and so on. So many times, again, I'm not trying to put a negative caveat on everything, but when we develop models, we always have to be sure of all the parameters that go into these boxes we put in, like fire residence time or rate of spread. Okay, so these parameters are sometimes knobs which can be used to change solutions to match observations better. So you have to explore the sensitivity of the model to various parameters. You need to constrain them as best as you can, and so on. So that's what is needed for reliable future projections of wildfires and their interactions with climate. So this is the estimate of average carbon releases from above and below ground wildfires over 1997 to 2008 in grams carbon per meter square per year. Obviously it matters that climate change is happening on top of natural variability. So 97-98 was a big El Nino, then which we know has all sorts of temperature and precipitation teleconnections across the globe. Then 98 to 2000 there was multi-year very strong La Nina, which also has seasonal teleconnections across the globe in temperature and precipitation, just like El Nino. And then you had a different flavor of El Nino happening almost every other year from 2002 onwards to 2008, with warming around the dateline. So these background natural variabilities also affect the wildfires, and unfortunately there are also interactions with human activity. For example, there is some evidence over Indonesia that El Nino prediction leads some artificial fires by developers who want to clear up land for palm oil or other development activities. Okay, so very complicated issue, but nonetheless you can see that there is some correlation obviously with the dryness, Sahel belt, rainforests, Amazonia up here in the temperate to boreal forests, and so on. Again, these need validations and so on. If we just look for trends, if you look at cumulative forest areas burned in millions of acres from 1985 to 2015, we have wildfires without climate change. So this is an estimate of natural variability that would have happened. And wildfires with climate change have added an oomph to the cumulative forest areas burned. Okay, so without going into the details on how this is done, obviously done with models, because the attribution is done by withholding some human activities and anthropogenic forcing to see what the natural wildfire variability would be if there was no climate change, and then what it has been because of climate change. Okay, so this is the MODIS moderate resolution imaging spectroradiometer monitoring forest fires. So you can see that this is a composite of many years. So you see all the hotspots of forest fire, wildfires, and including impacts of humans, of course. So study of fire seasons shows that the change in the fire season length is increasing about 2 to 2.5 days per year in these reddish areas, and there are some places where it has been reduced, but you have to be careful, because if it is reduced because the human activity has removed the fuel, or because the forests have already burned off, and so on, one has to be very careful about why this change happened, not only in terms of attribution of human causes, but also because of previous fires, how they are affecting length of the fire season into the future or over this time. The change of frequency of long fire weather seasons, percentages, again, there is some coincidence between the length of the fire season and the frequency of long fire weather seasons. So the global warming is changing the number of months with certain minimum nighttime temperature which is increasing, daytime maximum temperature which is increasing, and those sorts of things play into these as well. So stopping that there, I'll come back to a little bit more details about the fires and climate feedback loop which we will look at. So again, wildfires and fires are now being included in models like the vegetation interaction model that we saw with fire. Obviously that means with emissions as well in some cases. So the Earth system models now include human activity and these natural processes like wildfires and emissions from them, and the feedback between the fires and climate, climate on fires, emissions on climate, climate on emissions, and so on and so forth. So does increasing complexity of models actually increase the accuracy? Yes, it can, once we are very careful about constraining the models properly and validating them along the way.